Now, in this lecture, I've broken it up into two kind of distinct sections. In the first part, it's really a continuation of what we've seen in the previous lecture, in that we're going to continue looking at component lifecycle, at hooks, how hooks can actually influence the lifecycle, and also the area of data flow patterns. There is a second pattern that we need to be aware of because it is also commonly used. The second part of the lecture then will focus on navigation or routing. Any single page app, whether it be React or otherwise, is more than likely going to have multiple views or pages, and we need to allow the user to navigate between those pages. Now, just be aware, in this week's lecture in the archive, there are 3 subfolders when you unzip it. So just make sure you go down one level to import the relevant subfolder into VS Code based on whatever you're currently studying. So what you see on the left here is our filtered friends app that we had in the previous lecture, but I've made 2 enhancements to it. The first one is I've added a reset button, and the idea is when I click that, my app is going to make a new request to the random user web API to get 10 new friends. And I'll take that list of friends and overwrite the current list that I have. And secondly, I've decided that in the browser tab, I want to write some information there. In particular, I want to write how many matching friends are being displayed. So as the user types something into the text box, as we know, my app is going to compute the list of matching friends, and whatever number there is in that list, I actually just want to write it into the browser tab. That's clearly going to be another side effect. So from an app design point of view, I've stuck with the same design purposefully. And again, we're really only interested in this component here because that's where all of the lifecycle logic is going on. Because of the reset button, because every time the user clicks the reset button, obviously our UI needs to update. And so that means we need to have a state variable associated with the clicking of the reset button. So I've added a third state variable to my already 2 state variables. And the type of this reset button toggle, it could have been an int or anything really, but I've made it a Boolean. And it doesn't really matter whether I initialize it to true or false. The idea is that every time the user clicks the reset button, I'm going to change the value of the Boolean from whatever it currently is to the opposite. In other words, from true to false or from false to true. And that should trigger the use effect hook to make another API call. In terms of side effects, I still have the side effect related to making the API call, but the writing of information into the browser tab, that's also going to be implemented as a side effect. And in this case as well, our 2 side effects have very specific dependency arrays. You may remember in the previous lecture, my dependency array was the empty array because I only wanted the side effect that made the API call to happen once when the component mounted and never again. But now that particular effect needs to run at mount time, of course, but it also needs to run every time the user clicks the reset button. And in the case of the second side effect, the one that's going to be right into the browser tab, that will need to execute every time. Essentially, every time the user types something into the text box, although not really, it's really if the size of the list of matching friends changes, if the length of that array changes, then this particular side effect should run. So let's look at the code first, I suppose, before I discuss that slide in front of us. And it's going to be this folder from the archive that you've downloaded. Now, as I said, the design from a component hierarchy point of view is the exact same. And so really the only source code that we are interested in looking at is the app.js, which has my top component in my hierarchy. Maybe I should just run it first. If you look over on the right, you can see the browser tab is telling me that there are 10 matching friends, which is correct. But if I start typing into the text box, now if you look at the browser tab, it says 1 matching friend. And the reset button then just does what you'd expect it to do. So every time I click the reset button, it just changes my list of friends. I've decided to overwrite the previous list of friends rather than add the new 10 friends onto the current array for no particular reason. It's just arbitrary choice. The code then for the top component. So the only changes are, here's my new state variable. Here's the use effect that we had from the previous lecture. What's new though is that its dependency array is referring to my new state variable, which makes sense, as I said, because every time the user clicks the button, I'm going to have an event handler which is going to change the state variable, and that should trigger the request to make a new API call. We had this from last week. This is just the event handler associated with the text box. This is the computing of the list of matching friends, which we had from last week. Here's the second side effect. And okay, this is how you write to the browser tab. This is very much old browser-based coding. But of interest to us is this here, that we're seeing that the length of the filtered list array, if that length has changed since the previous rendering of this component, then you need to write to the browser tab. Filtered list here is my list of matching friends that has been computed. And other than that, okay, here's my reset button. Here's the event handler. Sometimes if the event handler is a one-liner, which it is in this case, then you can actually inline the event handler in the actual button itself, as opposed to how I did it up here, which was I'm referring to an external function, if you like, declared in my code. And from a runtime behavior, then you can see as well now that I've got some console.logs scattered around this component to help me understand the flow as the user interacts with the app. And that's what I'm showing on this slide here. So again, hopefully you can make sense of these things now. Just to go through it once more. So my top component renders for the very first time when it mounts. We haven't made any API call yet. My full list of friends is going to be the empty array. It will compute the list of matching friends, which is still going to be an empty array. My two side effects run because side effects always run at mount time. So this one is going to make the API call. This one is going to update the browser tab, essentially saying I have 0 matches because the computation has been done. Because this made an API call, eventually the API response is going to come back, and that's going to trigger a state change, which is why my component renders all over again. I now have 10 friends, but I haven't entered anything into the text box. I have 10 friends, so that means when it computes the list of matching friends, it has changed. It was 0, it's now 10, which means the side effect that updates the browser tab needs to run. So all of that has happened during mount time, I suppose you would say. Then let's suppose the user types something into the text box. That's really the same as last week, having typed something into the text box, that triggers a state change. The component re-renders again. It computes the list of matching friends, which let's suppose it'll be less than what it was. It was 10, it'll be something less. So the size of my list of matching friends has changed, which means the side effect that updates the browser tab needs to run. Then let's say the user clicks the reset button. That triggers a state change, which means the component re-renders again. The use effect that makes the API call is based on the state variable associated with the clicking of the reset button. So that's why this happens. Eventually, the response comes back from the API, which is why this happens. And it computes the list of matching friends, which is a different value, presumably, which is why this happens. It will go back up to 10 again, essentially. I'm assuming now that the text box has been cleared. It may not be 10 actually, but it'll be something different anyway. It'll be whatever value is currently in the text box, and it'll compute the list of matches of the new set of friends that have been returned from here. So again, just make sure, and you can play with it yourself in the browser, that you're happy with that kind of flow of control. And this slide is essentially just expressing all of that in text, so you can read through that yourselves. Now, I want to go back to data flow patterns. And the last day I said that the unidirectional data flow was the main pattern, which meant that data only flowed in a downward direction from parent to child. Now, there is a second data flow pattern, which is called the data down action up. And it doesn't contradict the unidirectional pattern, but this second pattern deals with a specific use case that does arise quite a lot. And I'll explain in a second what that use case is. That probably deals with the next slide. So I'm posing the question here, if you can visualize it. So you've got a stateful component, but the event that is going to cause that state to change, the event is actually linked to another component further down the hierarchy. Now that, which I'm calling the subordinate component. So the subordinate component, it's the component that's going to have the event handler, whatever the event handler is, whether it's the user clicking a button or entering something in a text box or moving the mouse. That event is being caught by a subordinate component, and it needs to tell the stateful component, which is higher up in the component hierarchy. It needs to tell the stateful component that it should change its state variable value. And of course, that will trigger the re-rendering, etc., etc. Now, so far, the examples that we've had, you see that the stateful component was also the component that handled or that caught the event associated with the user interaction. So they were part of the same component, so that it wasn't an issue. Now, the way we handle this new use case is by applying this data down action up pattern. To illustrate it, I'm sticking with the same kind of use case or the same application, but I've slightly redesigned it. And in the redesign, what I've decided is I'm going to have the text box being managed by a separate component. Previously, this text box was managed by the top component in my hierarchy. I've gotten rid of the reset button now and the updating the browser tab just to keep things simple. So there's a new component that's just going to be responsible for managing the text box. And this is going to be my component hierarchy. And as I keep saying, don't worry about how I come up with this, just accept it and understand the hierarchy is all I'm expecting from you at this stage. So here's my new component here. This is the one that's going to manage the text box. However, this is still the stateful one. This is the one that needs to know what is the current value of the text box so that it can compute the list of matching friends. But it's this component that finds out that the user has actually changed the text box. So it needs to communicate to this one that it needs to make a state change. And the way it works is the stateful component will pass a function down to the subordinate in the form of a prop. So now it turns out that props can be assigned data, or they could be assigned functions, which is new. So what the subordinate, the search box, does with that function then that has been passed to it is whenever the event occurs, in this case, the user entering something into the text box, the event handler will simply invoke the function that was passed down to it as a prop. So it's effectively invoking a function that's resident above in the stateful component. And of course, the function will actually carry out the state change. So the pattern is you've got a stateful component. In our case, the friends app component, it provides a callback to the subordinate, which is our search box, and the subordinate invokes it whenever the actual user event, if you like, occurs. So I'm just going to show you excerpts from the application, and you can look through it yourself. So this is the friends app component, the top one in our hierarchy. And here's the callback that it's going to provide to its subordinate. You can see it's making this state change. It's passing that function down as a prop to my search box component. Here's the search box component. And here's the event handler associated with the user entering something into the text box. And in the event handler, I'm going props dot, the name of the callback that was provided to me, and I'm passing as an argument the current value of the text box because the friends app component needs to know about that. So it's essentially calling something higher up in the hierarchy. And really they're the key parts of the application. So just quickly import it, I suppose. So you'll find the source code in this folder here. And I've shown you the really important parts, really. So app.js, my two state variables from before, the side effect, which hasn't changed. I've gone back to my empty array now as being the dependency array because I don't have the reset button. Here's the event handler for essentially the event handler for the text box, but the text box is not part of this component's JSX. So this is the callback that's going to be passed down to the subordinate. This is where I'm computing my list of matching friends. And we've seen this from the slide. So you can look at the detail and run it yourselves. So this is summarizing really what we learned from the previous lecture and in this lecture. So state variables cause components to re-render, as we know. Typically, the logic associated with making a change to the state, in other words, invoking the setter method, typically that is going to be part of an event handler because it's usually user interaction that triggers state change. And the way we handle user interaction is by having an event handler in our code, in our component, whether it be an on-click event handler a mouse move event handler, a button click event handler. You can have other logic in the event handler, but at some stage you will call the setter method or the mutator for your state variable inside that event handler. And as we've just seen, the event handler may not actually be part of the stateful component. It may be in a subordinate component. It has to be subordinate. It couldn't be a component higher up the hierarchy. That won't work, and nor will it arise. In terms of side effects, then, the only thing we haven't seen is where a side effects dependency array, because it is an array, could have more than one variable. It's a rarity, but it may arise. In our case, the dependency array just had one or no element in it, but it may have multiple elements. And it just depends on the use case, really. And in terms of data flow, we have the unidirectional pattern and the now data down action up pattern. Data down action up, as in data can only flow in a downward direction, but actions can flow in an upward direction because your subordinate can trigger an action of something higher up in the hierarchy, hence action up. Now, I've mentioned a number of times how the React design team made a number of conscious design decisions which distinguished it from its competitors. Another one of those relates to how it works internally, which is worth just being aware of, even though it doesn't necessarily impact on your implementation. And it centers around how React works with the browser's DOM data structure. We know that the DOM is, or I will refer to it as the real DOM now, it's an internal data structure representation of what's currently being displayed on the screen. And it dates back to when the browser was mainly used for the static web world. So the idea was that you, as the developer, coded up static HTML pages. When they were sent down to the browser represented that HTML in the form of a data structure, a JavaScript object data structure, which we call the document object model, or DOM. And then it uses that DOM to decide what it should paint on the screen. From then on, any alterations made to the DOM, usually by JavaScript that's running in the browser, those alterations will be reflected in what is displayed on the screen. So we know all of that. But the point is that the DOM really relates back primarily to the early days of the web. So it's not necessarily the most efficient or appropriate data structure for the dynamic web world that we live in today. The dynamic web has been around for quite a while, and we have been developing web apps for quite a while, albeit not using single page app frameworks. And back in the pre-single page app framework days, when people were still developing web apps, then the developer had to gain a lot of knowledge and understanding as to what was the most efficient way of updating the DOM. By efficiency, we mean to maximize the performance of the web app. And there were various good practices and bad practices, which really the developer had to learn over time. Now, one of the decisions that the React design team had to make was, should they assume that all developers were equipped with the necessary knowledge to make those good and bad implementation decisions when they were developing their web apps? And they probably made the decision that perhaps not. So for that reason, the React design team said, we will take away a lot of the responsibility from the developer for making good and bad design decisions in terms of how they implemented their JavaScript, and that JavaScript that manipulated the DOM. And they introduced something called the virtual DOM. So the virtual DOM is a data structure that is constructed and maintained by React, and it is a mirror of the real DOM, or I suppose vice versa. So we now have the virtual DOM, we have the real DOM, and then we have what's painted on the screen. So when you write components, the components that you're actually writing are not, when the component renders and re-renders, it's not actually manipulating or making changes to the real DOM, it's making changes to this virtual DOM data structure. So this is how React works behind the scenes. And I've kind of alluded to this a number of times, but I haven't mentioned the role of the virtual DOM. And so what the virtual DOM is, I'm saying there is that it's much more efficient and appropriate data structure for the dynamic web world. And your React components, so if we can imagine when a React component goes through a state change and it re-renders and all of its children and siblings re-render, that re-rendering process is actually making changes to the virtual DOM data structure. And when all of the re-rendering has completed, React then looks at what has changed to the virtual DOM and it performs an efficient batch update to the real DOM. And of course, once the change is made to the real DOM, then the browser reflects those changes in the actual screen. So that's what's really happening behind the scenes. And the reason that React design team introduced the virtual DOM were obviously for efficiency and optimization reasons, but also it meant that your code was much cleaner and less clumsy and less spaghetti code-like. If you did happen to get your hands on web app developed pre-single page app days, then the volume of code was very significant and it was typically quite difficult to maintain. So there were those benefits as well from a developer's point of view, but really one of the main reasons they introduced the virtual DOM was to improve the performance of your web app. So we've seen this before, actually. This was from last week, I think, where I explained what goes on behind the scenes when the user interacts with your web app. The interaction causes a component state change, etc., etc. So all that's happened, the only change that I've made now to this slide, which we've seen before, is down here in the pre-commit phase. In the pre-commit phase is where React looks at what has changed in the virtual DOM. It carries out a diff operation between the previous version of the virtual DOM and the current version. By previous and current, I mean what was the state of the virtual DOM before one of your components experienced a state change and subsequently went through a re-rendering process. And having gone through a re-rendering process and all of its siblings re-rendering, there's now a new version of the virtual DOM. And so it does a diff operation between the new version and the previous version, as I said, and then it carries out a batch update to the real DOM. So that diff operation is performed by React, and that's really what happens in the pre-commit phase. So now I want to talk about another aspect of web apps, which is navigation or routing. How do we do it in a React app? By routing, we mean we'd like our web app to have multiple views or pages. And as the user navigates from page to page, we'd like the URL in the browser to change accordingly. So each page will have its own unique URL address. And of course, that's a fundamental principle of the way the web works. Back in the static web world days, as we clicked on a hyperlink, that caused the browser's URL address to change and the new page appeared on the screen. What was the benefit of that? What was the reason behind it? Well, first of all, that is referred to as addressability. Each page had its own unique address. And the benefit of that was If I wanted you to see a particular page, all you needed was its unique address and you went straight to that page. You didn't have to go to a kind of a base page and then follow a series of links to get to the particular one that I was interested in sharing with you. So this addressability, information sharing, deep linking, they're all interrelated principles of the web. And we'd like our web apps to maintain those characteristics. Web apps that predate the single page app framework, they did not support addressability, which was one of their main weaknesses. So it was released when single page app frameworks came about that the addressability feature was reestablished, if you like. And in React, so one of the points I made about React when I started this module was to say that it was completely focused on the V part of MVC, didn't address any other aspect of a web app. And so that's the case with navigation. It doesn't actually support navigation at all. We need a separate library to do that, or a separate framework. There are a number of them, but one has emerged as the most popular one, and it's called the React Router library. But it is a separate library maintained by a separate community. Now, the third folder that makes up this week's archive contains various routing samples, some of which I'll talk through in this lecture, and the remainder we will look at in a subsequent lecture. So if we import this third folder into VS Code, as usual now, this was created with the Create React App, and you do the usual of npm install npm start. Now you can see there are a whole series of samples, and the way I want you to kind of work this is whichever particular sample you want to play with, you first of all have to go into the base index.js and change that to refer to the particular sample subfolder. And once you save that, then the development server will go through its retranspilation process as usual. So here's the first sample that we want to look at. In the table, I'm showing you my objective. I want to have 3 pages in my app, and depending on the URLs there, I want a particular component to be mounted onto the DOM. So for example, if the browser's URL is currently /about, then the about component should be mounted onto the DOM. It may have siblings. That doesn't really change how I express this overall table to the React Router library, or how I express its configuration. So at any one time, one of these 3 components is going to be mounted onto the DOM. And this is how I describe this configuration to the React Router library. So it's consistent with React itself. It's based on a kind of a component model. Now, in the outer components, the browser router and the switch components, they're kind of boilerplate, even though they play an important role. The browser router component, it essentially watches what's happening to the browser's URL address. And if that changes, that triggers an event, and the browser router component deals with that event. And by dealing with the event, I mean it essentially examines each of these route entries here to find a match. So if the browser's URL changes to /inbox, for example, it will realize, well, that matches this path here, and therefore it will mount this component onto the DOM. So these are components. These are components that are defined by the React Router library. So path is a prop, component is a prop, and all of that good stuff. So that's how we configure the React Router library. Notice as well that this component here, which I've called the app component, it's the one that we actually pass to the React DOM.render method. So the very top component in your component hierarchy is always going to be a React router configuration component, which is what I have here. So what's nice about React Router is that it follows this declarative programming model, which we've talked about before. The browser router component plays the role that I've explained there a moment ago. It finds the matching route entry in the set of routes that are available to it, and it mounts it onto the DOM, mounts that route entries component onto the DOM. The route, what I'm saying there in that point is that this path prop, it can have wildcard characters in it. So it does support a certain element of regular expression matching. The redirect, oh yeah, that's the last one there. It's always the last one really in the series of routes, and the redirect essentially avoids the 404 problem. So if the browser's current URL is none of the three that are on my table here, then I don't want my app to just throw back a 404 response. I want it to go to a default view or default page. And in my case, I've decided that this should be the default. And that's really what I'm expressing in the redirect entry here. So if and here's the wildcard character, for example. So if the browser's URL is none of the above, then I'm telling it to reset it to the /path. And of course, once the /path is entered into the browser's URL, the React router is going to make a routing decision based on that. And so it's going to pick up this route entry. The switch component, which the switch component behaves like a case switch statement in programming. So whenever the browser's URL changes, only one of these options is going to be picked by the React router. If we didn't have the switch, then it could pick more than one, and usually we don't want that. So if we look at the full code for this, so I've got my base index.js set to sample1, and I'll restart my development server. So if we dig into the sample1, now for convenience, I've essentially put everything into one file in here. So it has my routing configuration. It's what we've discussed already. And these other components that it's mentioning are also defined in the same file, just for convenience, really. And so for now, I'm going to manually change the browser's URL, which obviously isn't great, but so if I change it to /about, and if I change it to something that it doesn't recognize, then it redirects me back to the home page. So that's the 101 example. You write your routing configuration, put that into a component, and that's the component that you attach to the DOM. The next thing I'd like to do is to have hyperlinks on my web pages. And there is a special component that comes with the React Router library to do that, which is called the link component. Essentially, if you want to have links to something outside of your app, then you can use the traditional HTML anchor tag. But if you want to allow the user to navigate within your React app, then you should use the link component. It will provide other benefits later on, as we'll see. So to illustrate this, let's supposing on my home page, I'm going to have these two hyperlinks. How do I implement these hyperlinks? I'm showing you here on the right. So here we're using the link component. And for now, it just has one prop called the top prop, which we initialize to what we want the browser's URL to change to when we click on that link. So it's going to be a string in this case, but we'll see later on that we can actually assign an object to the top prop as well. So again, what's going to happen now behind the scenes is when the user clicks on one of these hyperlinks, one of these entries here is going to change the browser's URL to a new value. That event will be picked up by the React router. It will consult its routing configuration, and by that I mean it will look at this kind of stuff to decide which component should be mounted onto the DOM and also which one should be unmounted. And so that's what I'm kind of describing there at the bottom of the screen. Let's look at the code. So as I explained, you need to change the base index.js to now refer to sample2. Now, ideally, of course, we'd like these hyperlinks to be constant across all our pages. We'll see how to do that in a later sample. The next feature we want to look at is what React Router calls dynamic segments. More commonly, this would be referred to as parameterized URLs. So if you take the example here, supposing I've got an app and this is one of the URLs that it needs to support, but the idea is the 22 here is a parameter or a variable. Maybe in this case, it represents the user's ID. And let's supposing the component that mounts as a result of the browser's URL changing to this, that component would display this particular user's profile. Later on, maybe the URL might change to /users/50, and then it would display user 50's profile. So the component is adapting, or it's extracting information from the browser's URL in order to display relevant information rather than being purely static information. Similarly over here, maybe the component that's mounted as a result of a browser showing this path name would display a list of purchases made by user number 12, but clearly the 12 here is a variable or is a parameter. So how do we express URL paths that have parameters buried within them in React? And secondly, how does the component actually extract the parameter in order to use it? To link it back to our little case study, our case study is Maria, an email client. So where it might come in is, let's supposing we want our app to support URLs that look like this, where this is the variable part, and this might be a user's inbox identifier. Now, all I'm going to do is show you that the component that's mounted can actually access this piece of data. It'll just display it on the screen. I'm not going to do anything with it, but that will be sufficient to prove that the component can actually access it. So the first part of the puzzle is how do we tell the React router in our configuration that there is a parameter within the path name, and this is how we do it here. So the colon symbol tells us that what follows is a parameter. You can give any name to the parameter that you want to. So I've decided to call it user ID, but that's essentially kind of a variable name. So that tells React Router where a parameter exists within a path. And then the next thing is how does our component that's mounted access this particular value? So there's a couple of steps involved in this now. Well, strictly speaking, it's going to be passed in as a prop. Now the prop is a special prop that is created and injected into our component by the React Router library. So the prop is called a match prop. It's an object. It has a key called params, which is also an inner object. And that then will have a key based on the parameter name that you decided from your routing configuration. So this entire expression here is going to access the inbox identifier or the user ID from what's currently being displayed in the browser's URL address. Now, this expression just doesn't work suddenly. We've got to do an extra little bit of coding in order to get it to work. Ordinarily, this would throw an undefined exception back at us. So how do we resolve that? And the answer is here. We've got to use a special function that's provided by the React router. And you pass your component to this function and it returns an enhanced or enriched version of your component. And notice that's what I'm actually exporting here. So it's the component that is returned by this function. That's what you need to plug into your routing configuration. This with router function is classified as a higher order component function. Higher order component functions is a technique that we use quite a lot actually, or certainly it's used by a lot of third-party libraries and the React router, the React framework itself. And in general, it's a technique where you can use it to take one of your components and enrich it with some extra aspects. In this case, the enrichment comes in the form of extra props that are made available to us. So for example, the match prop and the history prop are two that are made available by the with router function. So let's see all this in action. Moving up to sample 3. Now we'll look at the code in a second, but I've got two hyperlinks here on the home page just to illustrate it. So when I click on these, if you just observe what's happening in the browser's URL address. So if I take this one, so we have /inbox/1234, and the inbox component is mounted, and I'm proving to myself here that I'm actually being able to access that particular inbox number. Essentially, I'm getting it from the browser's URL address. If I go back to the home page and click on this link, now it's 4321, and my component is actually picking up the right value. So I'm proving to myself that my inbox component can access the parameter that's contained within the URL of the browser. And this is the component that the code that we saw there a moment ago. So the full sample. Here's my routing configuration. So all that has changed is this one here. Here's my home page with the hyperlinks. And I've used both examples actually. I've programmed one of the hyperlinks using the link component. I've programmed the other one using the anchor tag. Both will work in this case. I should probably have used the anchor tag here as well. Or sorry, I used the link component here as well, but the anchor tag will work. So here's my inbox component. And as I've already said, it's what the with router function generates, that this function takes your component and outputs a new component. And it's that component that we're actually exporting. So that's the one that is being injected into, or that is being wired into my routing configuration. As in here. So far I've said that all of our routing configuration for our app is centralized in one component, which is at the top of our component hierarchy. But you can actually have route entries contained within your own custom components. And we would refer to these, or the React Router library refer to these as nested routes. The general kind of use case for it is if one of your components, if one of its children is somehow determined from the browser's current URL address path. So to apply it to our little case study, so this is one of our standard routes that we have at the moment. But supposing we have a case where the URL address could actually look like this. In other words, there's a /statistics part. And if the URL is like this, then we want both the inbox and a stats component to be mounted onto the DOM. So the stats component is going to be a child of the inbox. Whereas on another occasion, the URL might look like this. And if it is, then we want our inbox component to render a draft as one of its children. So the routing logic that would achieve these two, we can put that routing logic into the inbox component. We don't have to put it in the top level routing component. And so here's an excerpt from the inbox component, and you can see as part of its JSX, we actually have route entries. And the route entries are referring to the particular child that I want to have mounted in addition to the inbox. So let's see the sample in action. So again, I've just got some hyperlinks to demonstrate it for convenience. So this hyperlink is telling me that it's just going to mount the inbox component on its own. But if you observe the URL now, so the URL looks like this, and the inbox component is generating this, which we had from before. Whereas when I click on this hyperlink, you can see that I have /statistics as part of the URL. And so now what I'm seeing is the inbox component is generating this output, but the stats component is generating this output. And the third example then is I have a URL that has /drafts as part of the inbox. So now the inbox component is generating this, and the drafts component is generating this. I still have my about and home as before. They haven't changed. And so most of this sample is as before. So that hasn't changed. So my top level only has a reference to the route that would cause the inbox component to be mounted. There are my convenient hyperlinks just to demonstrate it. And the inbox component then is, as we saw from the slides. So you can have these route entries buried within your own custom components. Now, you know, that's really a kind of a design decision as part of the overall design of your React app, deciding what are the different URL paths that it should support, and then identifying opportunities to use these nested routes might be part of the design process. The last example we'll look at in today's lecture is extended link idea. So when we click on a hyperlink that's programmed with the link component, okay, our new page is mounted, but supposing we wanted to pass some custom props to that page that it would use, how do we actually do that? And it turns out that there's two forms of the link component that allows us to do it. So to demonstrate it, it's kind of an artificial demonstration really, but let's supposing in my inbox hyperlink here, which I've implemented with the link component, I want to pass some additional props to the inbox page itself. And this is how I've programmed it. So here's my link component, but the top prop this time takes an object rather than the string as before. And the structure of this object is dictated by the React Router library. So my path name is specifying well what I want the URL of the browser to change to. And here is how I pass the additional props. Now I've hard coded them here, but presumably they would be computed in a real life situation. So the stats object has a set of key value pairs. And these key value pairs now are going to be props that will be made available to whatever component is mounted as a result of the browser's URL changing to this. In our case, in our top level routing configuration, it's going to be this route entry here is going to match it. And that says you should mount the inbox component, and inside of the inbox component, this is how I get at the additional props. So essentially this props.location is another special prop that's made available to our component by the React Router library. And all I'm doing here is destructuring the stats object to get at my two custom props. I'm not doing anything with them other than displaying them, I think, but it's sufficient to demonstrate how you can pass props to a component via a hyperlink. And you can look at sample 5 in your own time. Now, there's just one or two aspects of the router configuration that I want to go back to, and I'll demonstrate them using sample 1. So here's our configuration, and we know how it works. So if my URL changes to /about, it goes to the about page. I go back to the home page, and let's say the URL is /about/us. It still finds the about page, and that's because it's the nearest match that it can find is how it works. So that URL there is the closest closest to it is this one here. So it's happy with that. Now, you might notice down here, I'm using an extra prop called exact. If I had used that up here, essentially now I'm saying the URL has to match this exactly. Otherwise, don't use this route. Try and find another one. Of course, it won't. But if I save that, and now if I go to the About page, and now if I try /about/us, this is now going to send me back to the home page because this URL doesn't match the /about route exactly. The second point is the order in which you put these may affect how your app behaves. So what the React router does is it goes through these in the order in which they're presented, and the first match that it finds, that's the one that it accepts. It doesn't go looking to see, is there a better match further on in the list. So let's make some changes here. Let's get rid of this. And also let's move it up to here. Okay, so that's our routing configuration. Save those changes. And what we're going to find now is if the browser's URL is /about, then obviously this will apply. But when we make it /inbox, it won't actually use this one. It's going to use this one because I've gotten rid of the exact prop here now. And so this is the nearest match so far that it will have found for a match to /inbox. Let's prove that. So that's my home page. About works. But inbox brings me back to the home page. And the reason again is because this URL, when it tries to look for a match, obviously this doesn't apply, but this is a close enough match. It's not an exact match, but I didn't say it had to be an exact match. So it decides, well, this is the route that it will use. It never actually gets to check this one at all because it is already determined this will do. If I reinsert the exact prop there though, now I'm back to the kind of behavior that I had before. So if I go back to the home page, so the point being, number one, you do need to pay attention to the order in which you put these, and you should use the exact prop on certain occasions to ensure that the right route is picked. And it really depends on the specifics of your app as to whether you need it or not. Now, there are some other samples that we need to work through, but we will cover those in a subsequent lecture.